All right, so we're going to do 7-3, taking square roots of functions, and we're going to be graphing these. But before we start, we have a little warm-up for you here. So hopefully you pause the video and try these on your own, and then we will talk about them together. So both of these functions are actually quadratics, and these are things back from chapter 5, and we talked about it a little bit in chapter 6. These are quadratics or parabolas in vertex form. So this, whenever there's something on the inside, remember that moves it left and right, and it's always the opposite of what you think. So that is actually going to be moving it left 3. Then anything that's on the outside, you would be moving up and down. This one's exactly what you think, so this would be up 1. Okay. So then on number 2, we only have one added thing to it, which actually technically is 2 added things. We have a -4 on the outside, which means that it is going to reflect over the x-axis. And it is also going to vertically stretch. Okay. So again, inside, left and right, because it says -2, that's going to move right 2. And on the outside, +3 means up 3. All right, so that just served as a little reminder as we keep moving forward. We are going to talk about square root functions, which are pretty much parabolas, except you're going to see just either the top part or the bottom part of a sideways one, okay? So instead of a U, it's going to be looking like that, all right? But let's talk about the parent function of it. This is kind of just the generic form. So if we use this equation and we just plug in some numbers for x, let's go with 1, 0, 1, 4, and then let's do a 9. The reason why I'm picking all of those is because each one of those has a square root. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 3, or 9 is 3. Okay, so let's go ahead and plot those points. 0, 0, 1, 1, 4, 2, and 9, 3. Now again, if you think about it, over 1, up 1, over 1, up 3, over 1, up 5, it's the same thing, it's just sideways. Okay, but that's not always going to be the case. But let's talk about domain. So domain, your farthest left, or your farthest x value to the left, would be 0, and it's included. And the farthest right is clearly infinity. Your range actually gives you the same thing because our lowest is 0 and our highest would be positive infinity. Your x-intercept would be 0, 0 because that's where it crosses the x-axis. And that's also where it crosses the y-axis. Okay, so we're going to focus on transformations with this. Okay, so remember you have your h and your k, which does indicate your starting point, just like it did with parabolas. And then the same rules apply with a. Okay, it flips if a is less than 0, and it stretches or condenses. So the whole flipping is actually reflecting. Okay, but remember, if it's a bigger number, it's stretching. If it's a fraction between 0 and 1, it would be compressing or condense, either way you want to say it. Domain pretty much always is going to be x is greater than or equal to h, and range is going to be greater than or equal to k. Okay, so let's take a look at some of these examples. All right, first off, how I want you to do this is always use the 0, 1, 4, 9 aspect that we've been talking about from the other one. Okay, and then that made this one 0, 1, 2, 3. Right, so you're using those to help transform the rest. All right, so on the left for your h, or for your x, you're always just going to add h. Okay, and on the right for your y values, you are going to multiply by a and then add k. Okay, and that's the process that you're going to do every single time. So let's think about what we do have here. All right, this makes h 3, and this makes your k 2. So that means on the left, we're just going to add 3 because that's what h is. So we get 3, then 4, then 7, then 12. On the right, we do not have an a value really, okay, it's 1. So you're going to multiply by 1, which you don't actually have to do because it'll just be itself. And then you're going to add 2. So you would get 2, 3, 4, and 5. So let's go ahead and plot those points. 3, 2, 4, 3, 7, 4, and then obviously the 12, 5 would go away. It's way off the graph. So my domain, farthest left is your 3. Farthest right is infinity. And for your range, your farthest down is 2, and your farthest up is infinity. And again, that comes from your h and k. It's always going to be pretty much greater than or equal to or less than or equal to that number. You're involving those in both. So if we're listing the transformations, the 3, our h being 3, moved it right 3. And the k being 2 means it moved up 2. This is the process we're going to follow for the whole day today. All right, so again, we are going to start with 0, 1, 4, 9, which if you take the square root is 0, 1, 2, 3. From here, we need to identify our h, right? Well, our h comes from the inside. It says minus 5, so we are going to add 5. So let's go ahead and do that. This becomes 5, then 6, then 9, then 14. On the right, we need to multiply by a and then add k. Well, this time we actually do have an a value, so we're going to multiply by 1/4, and then we're going to add our k value, which is 3. So the first one gives me 3. The next one would be 1/4 plus 3, which is 3 and 1/4. The next one would be 1/2 plus 3, which is 3 1/2. And the last one would be 3/4 plus 3, which is 3 3/4. I don't care if you put decimals, that's totally fine with me as well. So let's go ahead and graph this then. We have 5, 3, 6, and 3 1/4, 9 and 3 1/2, and just estimate it. So it's going to be going up much faster this time. So our domain farthest left is going to be our k or our h value, which is 5. Farthest right is infinity. And for our range, our lowest is our k value, which is 3. Highest is infinity. Transformations wise, we have a 1/4 on the outside. So when a is 1/4, it is a vertical compression or condense of 1/4. We also had the 3 on the outside, which moved it up 3. And then we had the 5 on the inside, well, the negative 5 on the inside, which remember is always the opposite, which means we moved right 5. I'd encourage you to try number 3 and 4 on your own before you watch the video. So go ahead and pause it and do it on your own, and then we'll go through it pretty quickly. So remember that you always start with 0, 1, 4, 9, and then 0, 1, 2, 3. So on this one, we have to add h, but there was no h to add, so it just stays 0, 1, 4, 9. On the right, we need to multiply by a, add k. So we're multiplying by 3, subtracting 2. So the first one gives me 0. The next one gives me, oh, let me try that again. 0 minus 2, which is negative 2. The next one gives me 1, and then 4, and then 7. So we can go ahead and plot these. We have 0, negative 2, 1, 1, 4, 4, and 9, 7. So much wider one. So domain, our h value is 0, so it's going to be 0 to infinity. Our range is going to be k to infinity, which is negative 2 to infinity. Notice how these are pretty much R, H, and K every time. And again, you don't have to memorize it being H to infinity, K to infinity. You can just base it off of the graph. Our transformations, that 3 in front, it means that it is a vertical stretch of 3. And the -2 on the outside means down 2. For number 4, we're starting with 0, 1, 4, 9 again, and then 0, 1, 2, 3. So on this side, we would subtract 2 because it's always the opposite sign, right? So -2, -1, 2, and 7. And on this side, we're going to multiply by -1 and then subtract 4. So we get -4, and then we get -5, -6, and -7. So we plot our points, -2, -4, -1, -5, 2, -6, and 7, -7. So on this one, our domain is going to stay the same, right? It's going to be from -2 to infinity, but our range is going to be -infinity to -4. Notice how this goes from the bottom, right? This is going to keep decreasing. So it's going to be from -infinity to -4 instead of -4 to infinity. Okay, this definitely is the bottom part of it. And that only happens when we have a negative on the outside because that means that it is reflected over the x-axis. The 2 on the inside moved it left 2, and the -4 on the outside moved it down 4.